as has been given by the PowerPoint presentation, which I've already emailed to you through the Google Classroom. But before I actually start with those commands, we need to understand what are these networking commands for. See, are you recording this? See, are you recording this? All right, fine. So I will close my video. I will share the screen. I'll first inform you when we are actually chatting with each other, how does this chat go through? What are the technologies? What are the intermediate nodes that we come across? For that, I will share the whiteboard. I won't need my video as of now. This might lag the transmission. All right, can you see the whiteboard? Fine. Good. So let's first try to understand from here what we are doing. At a corner here, I made a red box. This is you, let's say Ramanand, chatting with his friend who is at the top right corner here. Okay. Now Ramanand is, let's say, in NIT and his friend is somewhere in, let's say, United States. What comes in between? Generally, you might have seen many figures which show something like this. This is known as a cloud, an internet cloud. Now, what it basically is, let me see. It consists of several devices which come in between. To begin with, Ramanand here would be connected. Let's say Ramanand is sitting in our computer department lab. His PC would be connected with a wire to a device known as a switch. Let's say this green box is a switch. From this switch, there would be around, let's say, 30 other PCs connected to it. A simple unmanaged switch, which connects later to another switch, which I will draw here, which is a bit bigger than this one. And this would be the main switch of lab. And after this, we would have another switch, which would be a managed switch, a bigger one of the department. Right? The first one, the blue one we can call as a hub, then the dark blue one, then the light blue one we'll call it as a switch, an unmanaged switch, and then we'll have a green one which we'll know as a managed switch. The green one transmits all the data from our department. Now this goes through to a main switch which is known as, let's say I'll make one more here, which is known as a distribution switch. What is a switch? This we'll understand. Is my audio clear? I think Arif has some Okay. All right. All right. I'll go ahead then. Okay. So we went to a brownish colored switch, which is known as a distribution switch. What is a switch? What is a hub? What is a router? We are going to discuss all of these devices in our coming classes. As of now, just remember these terminologies. Then from there, we move on to one more switch, which would be inside computer center. This distribution switch would be for our building, which has electronics as well. Then we have a bigger switch. We call that as a core switch. This is within the computer center. From the core switch, we would have, let me see if there's some other, a router which connects the core switch. What is a router? It's a layer 3 device. I will come to it once we reach there within the course. And this router is NIT's router. From here, we connect to another device, which would be a router of, let's say if BSNL is providing us the connectivity, it will be BSNL's router. This all is within our NIT, and from this core router, you would expect each of the department getting connected through the core switch. They would have a separate line like what I have drawn here just now. What happens next? This last router that I have drawn connects to the main router of the BSNL. This is the BSNL's router at NIT. It will have a router in, let's say, BSNL Srinagar office. This one. And from here, there would be, this BSNL would be sending other offices links from these routers. It would have connection for homes. So there would be a network of routers, something like this, within BSNL's network. And from this, it will connect links to the main BSNL office, which is in Delhi. It will have a number of trunks running from the last router of BSNL in Srinagar, connecting to the router at Delhi, BSNL's office, Delhi. So we reach to this end now. Now what happens here? All the internet traffic from a country is sent through across one point. And it happens that Chennai is the point from where the data is sent across for India. So this would connect to the Chennai router, and from there we would have all the traffic sent across through a number of links, typically fiber links, which are dug under the sea floor, then spreading across different continents and different countries. Now, If you are aware, many years back, it so happened that an earthquake happened somewhere near the shore of Egypt. And then internet wasn't working well. You could see that any site that was within India or within Asia, it could be accessed fast, but any servers which were accessed beyond Asia were slow. The reason being that these lines that were going across from the country's main point, that is Chennai, to the, let's say, America, those links were cut because of undersea earthquake. Now from here we reached to a point wherein we connected to the main internet providers within America. And what do we say here? Let's say if AT&T is the service provider, it connects here in California. From here it would have its links going to, let's say his friend is in New York, going to New York. So a router in New York. From there it would have links. Say, let's say his friend is sitting in, let's say, New York University, then we'll have a router connecting it to it. And then what do we see? Within the New York University, it will have a number of switches that is similar to what we saw here in NIT. Until it reaches to his friend. And now, here on my left extreme, Ramanand writes hi through, let's say, a messenger. And this hi goes across this all. And this hi would go across all these switches and routers, and somewhere in between these there would be a switch, a router. Let's say if you are connecting through Facebook, through these switches and through these routers, you will get connected to your friend. Whether you are using SIP or some other protocol, you will get connected to your friend. And then this hi passes through all these intermediate devices, right, which tens and tens of devices, to reach to your friend which is on the other extreme here, and he would hi. And he will reply back to you, hello, and this would take a fraction of second from one end to other end to reach there. Now, what was the purpose of showing this, figure? The main purpose is that there are a number of intermediate devices. Ramanand and the other person, his friend, are end hosts. These blue, black, green devices are intermediate devices. These intermediate devices constitute hubs, switches, routers, servers, firewalls, and so on. Each device we are going to study in coming classes. Now, what would be the purpose of today's lab? We would see in our slide, which I believe everybody should have downloaded. This is the lab number 2. Lab number 1 is actually that crimping, so we'll be doing it later on. This would give us an idea of, if I am talking with Ramanand's friend, how far is he from me? Means how many intermediate devices are there? How many hops is it? Or if I am connecting my PC to another PC, I am not able to send the data. I need to troubleshoot. How would I know, am I connected or not? I would have to have a command by which I can check my connectivity to other PC. There are commands by which I would get to know what is my address over the internet, what we know as IP address, and commands by which we get to know who is providing us domain name, okay, how much time a packet would take to reach to the place, and how much time it would take to come back, what we call as round trip time. What is the path that packet has taken from Ramanan's PC to his friend's PC? How many devices came in between the two? And so on. So to start with it, I will now move from this whiteboard. I'll just stop sharing and we'll go to sharing of a PPT. All right. Raman, is the PPT visible? Okay. So let's start with the basic networking commands that are necessary, and it's important for you also to know. This is the figure which I have drawn just now. This is similar to that, depicting, let's say, a red line, connectivity between M and N, the orange line, connectivity between the other two devices. How to detect if another machine is alive, how to detect the path of it, how to resolve DNS name to IP addresses, and so on. For this, we would require the networking command. The first command is a basic command and which is available in most of the devices that you use. So let's begin with the ping command. I am on slide number 3. Now, I want you to go to the command prompt. How you can reach the command prompt? If you have Windows 10, at the bottom there is written type here to search. You would be doing this along with me, everybody. So type search there, you write CMD. I'll type it in the text also, CMD, if my audio is not clear. And press enter. You would get command prompt. You got it? Ramanand? Okay, you got command prompt? Fine. So, good. At this, you will have C:, backspace, whatever name of the PC you have, users and so on. Type PING and then space a website. Let's say I'll say www.google.com, google.com. I'll type it in the text as well. Type this, ping www.google.com. And you would get a reply from it. Now what reply I got? I will copy and paste it inside the chat box. The rest of you, did you get the same thing? So this is my command, C user ping google.co.in. Why I used co.in? it means that I am pinging a Google server which is within the, within India. So you can ping others as well. If you some might not reply, some might say request timed out, which is that those servers, let's say, let me see if some server won't give me a reply. Ping www.yahoo.com. Well, it's also replying back. Some servers might not reply back. It might say request timed out. Several reasons for it. Either connectivity is not there. Okay, I'll repeat. Okay, now as it says, do we have to necessarily learn commands for Windows OS? I have a Mac OS and certain network utility commands are different. No issues. I mean, like for example, there will be some commands in which for Linux-based systems, you will have a different command. Like for example, ping for Linux is still ping, okay? Or let me see, trace route may be different for Linux. Are you in your command prompt for in the Mac? You are? It's still, try ping. So did you try ping? Yeah, fine. As long as you have Linux, you have Mac OS, some commands might not be there, but some commands might be there. The reason here being, like Abhinandu, is nitc.ac.in has blocked the ping command, means it will not reply to it. Certain security reasons in which, sometimes there can be a ping attack and so on, some servers would stop it. That's why I said sometimes you might get request timed out, sometimes you will get a reply here. Did you try some other, Abhinandu? Okay. So what is ping? Ping is a basic internet program that lets you verify that a particular IP address exists and can accept requests. So accept request is when it gave you a good reply that yes, within this time. Okay. Move to the next slide. Slide number 4. First, let me go back and see what was the reply that I got from the ping. I pinged google.co.in, pinging www.google.co.in, and in the bracket, you can see 172.217.167.195. So, what I have received here is that google.co.in is a domain name, or DNS. When you go to DNS gives you give the domain name to it, google.com, and DNS goes to the actual IP address of that. Why it won't be easy for us to remember 172.217.167.195? So easier way is google.co.in. As a human being, it's easier for us in that case. So it replied back you saying that I pinged google.co.in with this IP address, and it replied to you giving the IP address of google.co.in. This is the IP address of the server which you have accessed. With what? With a 32 bytes of data. A very small packet was sent. Why? You're not actually sending any data. You're just sending a control packet. This is known as a control packet, which helps you to test or verify your connectivity. And the reply from google.co.in was 32 bytes sent. Time it took was 238 milliseconds. TTL is 56. 4 of these lines are there. Means I have sent 32 bytes of packet, 32 byte size packet, and 4 times I have sent it. Okay. Now what is this time? Time is the round trip time. The time from which I have sent the request to the time by which I have received back the reply. This is the time given there. And there is another one, TTL. This is time to live. And what does TTL mean? It means that it can go to the maximum of 56, the time to live. Typically, it's given by hops. It can have 56 jumps. When I type CMD, I don't get TTL in reply. TTL 52 is there. Copy paste what you have got, and tell me what OS you are using. It's a command prompt. Command prompt does not take Control C. What you can go is, you can select, you will see white color there at the top corner where it's written C:, the icon. Click that, go to edit. There is written copy. That is simply, you can press enter. That's how you copy from it. Okay, you are in Windows 7. Do you go to command prompt, or you are not able to go to command prompt yet? Alright, until Marian you reply, I'll check what Swati is saying. Swati, sir, the reply is continuously going in my relax terminal. Okay. For Linux, break it, use Control C or Control Z. It will stop it. Control C, Control Z, use Control C or Control Z to break it. Otherwise, it will continuously move on. Okay, Marian, you are in command prompt. So what is ICMP underscore sequence? Right. This is basically a sequence number that you get. What is ICMP? ICMP is Internet Control Message Protocol, which is basically ping. Ping is the name of the application, but the protocol that the ping uses behind is ICMP, Internet Control Message Protocol. This is a protocol which belongs to network layer. We will be coming to it. The protocol behind ping is ICMP. You might have a different OS, that's why, yeah, because of you using Mac OS, that's why you get a bit different reply. Okay. So you, Marian, you are in command prompt. What is the issue now? Swati, did you get the break with Control Z? I think you can use your microphone as well for those who have questions. You can type in here and then ask from this microphone so that I can reply to you directly. Okay, Marian, request timer ping statics 100% loss. Then you ping this, you are getting request timed out. 100% loss. You are pinging this. Okay, that is what I meant, that some servers won't let you reply back. Okay, like your statistics shows, sent equal to 4, received equal to 0, lost equal to 4. So 100% loss. But when you ping google.co.in, you had sent packets 4, received packets 4, lost 0% loss. Approximate round trip time in milliseconds, minimum this, maximum this, average this. This should be fine. All right, for others also it worked? No questions. All right. Now, ping command, what you did was basic one. With it, there are certain available options. Like for example, in Linux, just now, Swati, when she pinged, she could not stop. She had to break the ping by Control C or Control Z. In Windows, it by itself took 32 bytes of data and sent these bytes of data as 4 different packets, each of 32 bytes. Now you do not want to send these many 32 bytes of data. You want to try to send a bigger amount of data. Okay. Or like Linux, you want to continuously ping the data. So for that, you can use different available options. Like I would use ping www.google.co.in, and I would use -t. If you move to slide number 4, there are several options given. Okay. For Windows users, use -t. You would see it's not ending. It's continuous. Now, as a network administrator, I want to see whether my server is active all the time. I'll keep on pinging it continuously. So I would have -t. For Linux, you don't need to use -t because you are pinging it continuously altogether. How about Mac? Mac OS, they can check it. Nawazish. All right. So fine. So it pings continuously. So we move on to the next one. There can be, like I just now said, bytes of data is 32. I do not want to send 32. I want to send bigger one. Like here it says maximum 65,500 bytes. Okay. Change it to some other size. So you can use -L. Okay. And with this -L, you need to mention how much. Okay. I wrote -L, I wrote 64. It got changed to 64 bytes. I will copy paste here, and you would see the difference between the previous one and this one is that the byte size is changed from 32 to 64. And it accordingly would increase certain times, like approximate round trip times. It might be a little bit higher. Okay. Now there are a lot of available, options for ping. Reload to value greater than 3. Try anything greater. Swati, try anything greater than 32. What did it give? Like ping www dot. I'll just write here google.co -l. Like this is the command that I used. Yes, Navi, for Linux, it worked. What is it given? If preload is specified, ping sends that many packets, not wait, reply only. Okay, what kind of Linux are you using? What flavor of Linux? Okay, try help ping. Type this. And see what options that you are getting in that. And then you can alter accordingly. C is count. Try packet size. C, packet size. Okay, fine. About Swati, you also try the same. Okay, working fine. So there are other options. I won't go one by one, then it will take us the time. We will just have to spend time on ping only. But one thing I will say here is for loopback addresses. Loopback addresses would be the host addresses that you are connected to, what you call as local host. A local host means that you have a network interface card or you have a Wi-Fi card in your laptop, and when you start your PC, you are not connected to any device, but your network card is on or your Wi-Fi is on. That means you would have your own address. This is known as a loopback address. This we also call as a local host. So what you can do is you can ping yourself. How? Try pinging localhost. I'll type it. Write this command, ping localhost, and you would get a reply back as this. I've copy pasted the reply. Now you can see ping localhost, pinging SQ, :1 with 32 bytes of data. Reply from the local host is time took less than 1 millisecond. Why? Because it's so fast that I'm pinging myself. Sent 4 packets, receive 4, 0. It would show an approximate round trip time of 0, 0, 0. Obviously, because this is your own system. That's why you have the least, round trip times. Okay, it worked for other operating systems as well. If localhost doesn't work, then try pinging 127.0.0.1. Try pinging this as well. You should have the same result in this case. Okay, the similar type of result, but it would look a bit different, that this many types of data time less than, it might have TTL also included within it, but it's just the same. Many systems would also ping their system names, what we call as host names. What I mean by host names, application layer, like we have IP address here, application layer also has its address, which we call as host names. Typically what your computer name is. Like for example, I have C:users SQ here. let me just copy paste here. This is my command prompt. So I believe SQ would be the name of this computer. SQ is for Shaima Qureshi. I'm using Shaima ma'am's laptop. I don't have my own. And from here, I can ping my device with this name. So I will ping SQ. I should get a similar kind of reply here as well. Try pinging that. I have pasted the reply of that here as well. Fine. Linux is working, and I believe then Mac should also work. If you don't know your system name, is it in any way different than pinging localhost? No, it is not different. The only difference is that if you write localhost, it's like a domain name of your system. It's like that. If you write 127.0.0.1, it's the IP address that you are pinging. That is the IP address, the local IP address of the system. If you're pinging the host name of your PC, it's the name of your PC at the application level, address at application level, which we will come to later on once we study the addressing. Okay, I'll move to the next slide. Nawazish, can you ask through microphone? Let's see how it works.
Yes, sir, I'm asking host ID of different user on a system would be same.
Host ID of different user on a system would be same. It's as long as your, what is the name of your PC.
Okay.
Normally, there is a single name for your PC. Remember, when you add your PC to the web or something, there is a PC name. That PC name would be same for all.
Okay.
All right. Okay, I was trying with Nawazish, so it works fine. You can ask questions directly also. Okay, ping request could not find host dream. Please check the name and try again. So your host name is not dream. You need to find what is your name of your PC. There's a system manager, system information. What's your OS? Windows 7. Okay. Let me see. Windows 7. Do you have somewhere like system you use to right click on the main PC? If there's a PC icon on your desktop, go to properties. That might give you the details of the system. Try to right click on computer. When you click on start button, try right clicking on computer, select properties, see what you get from properties, see whether it's dream or not. Yes, it's not dream. So yes, try pinging try pinging that name and see whether it works. Okay. I move on to the next slide, that is slide number 5. There's an example given. Since we took already the ping command here, we don't need to see the slide. But in the assignment, they would be given that you would have to work on this ping command. But I want you to try each and every option and see if it works or not. If it doesn't work, see, maybe you're using a different operating system. Then check it out what would be the syntax of your command, like your man this command and so on. Okay. The second command that we come across is known as traceert command. Move to slide number 6. Ramanand, is it visible, the slide that I'm sharing? Fine. Yes, traceert. We call it traceert command, which is a short form of trace route command. Okay, like for example, when I leave from my home to reach NIT, I can say that I left this house, then I came to this road, then I made a turn, then I went here. So likewise, when Ramanand chatted with his friend in the United States, there were intermediate nodes. Now I want to know that when he sent this hi as a packet, how many intermediate nodes did this hi cross to reach to the other end? So it would pass on as a hop, like one device to another device would be one jump. We call it as one hop. This command is a traceert command, or we call it as a trace route command. It would change in different systems. Some systems might not have it. They would have to figure out and install this command, like typically in the Linux. In Linux, try trace route, traceroute. Okay. In Windows, try traceert. Since I have Windows, I will say traceert, traceert. Okay, you have written trace route 6. Naveed, it's not actually the same trace route. That would remind me another thing. If there are two types of addressing here. We have IPv4 addressing and IPv6 addressing. This will come when we discuss about addressing in network layer. What we pinged just now is an IPv4 address. What IPv4 address was, like 127.0.0.1. Likewise, if I have to ping an IPv6 address, I need to use a command which is for IPv6. You can try this. You try ping 6. You would have to give an IPv6 address. For Windows, ping and ping 6 is same. You don't need to write ping 6 to ping a what you call IPv6 address. Okay. When you say trace route 6, it is to trace route for IPv6 address. Now, let me trace route. I would use for Windows traceert. I just now used traceert ping for google.co.in. Let me now do trace route for google.co.in. Trace paths also do. Use trace path. Yeah, has given that for trace. That's why I said at the beginning, you might not get, the command easily available in other systems. You would have to install that. Some are basic commands like ping, which comes there. Some you would need to install. How about Macintosh? All right, my traceert of Google.fine is complete. I'm copying, pasting it here in the chat. Let's try to understand what I have got. I have pinged the same google.co.in. Now I'm trace routing the same google.co.in. The reply from trace route is tracing route to www.google.co.in and then the IP address I got of the server that I had pinged. Let me do one thing first. I'll go a bit up and I'll check the previous google.co.in. Was this the same IP address that I had got previously? No. Or yes. At times it can be yes, at times it can be no. So what it means that Google has a number of servers. Since it gets hundreds and thousands of requests per second, so it can have one server replying to some queries and another server replying to another query. Anyhow, now tracing route to a maximum of 30 hops means it will go to 30 intermediate devices in between. On the left side, you will see 1, 2, 3, 4, 5, 6, 7, 8. So means to reach to this server, it went 8 hops. It started with 192.168.1.1. I'm connected to my Wi-Fi. So this is the first hop. My own IP address. Let me check. My IP address is 192.168.1.9. So it first hops to my local address here, to my router that I am connected. This is the first jump between my laptop and there. Then from here, it takes around, the time is given there, and then the name is given something like .bsnl.in, which means this is the main BSNL server I am connected to. Then BSNL server is connected to another server 218.248.235.233, which may be in Delhi. And then it is connecting to some server in between, or sorry, some router in between, which says request timed out. It's like the ping, some ping, you did not get the reply, you got request timed out. Why? They do not want themselves to be detected. They do not reply to your requests. That's why request timed out. So there is a hop there. But from here we get that, yes, there's a hop. From there it goes and it pings to another one that was 72 dot this, another. From there to another one, and then it reached to the last hop, which was the server of Google. That had the IP address 172.217.167.3, and it says trace complete. So my trace is not completing, it stopped in between. Can you copy paste and show us what error you are getting? Just copy paste your error. It is not showing you at all. That means the device that you are connected to is not letting you go through. It's stopping there itself. It won't let you pass. For others, it worked fine. Okay, fine. It says the next slide, I move on to slide number 7. It says various options available in the tracert command. -D, don't resolve addresses to host names. Like I got del.something.bsnl.in. I won't get the host names. I would just get the IP addresses if I use this. If I want to change the hops, by default, they were, the one which I used was up to the 30 hops. I can change the number of hops here by using -H. And so on. Like I said, for ping, this one also you would try all options and see how it works. The 8th slide, we just now gave an example try, so you would also try the same way. I don't need to explain this one. Okay. Now, if you're connected, like I am connected to my device here, I can trace search simply to that device to see how many hops are there. Obviously, I should get just one hop, you can try doing tracer to it. So I know the IP address of the device, the router I'm connected to it. So I did trace route to 192.168.1.1 and I got like I'm one hop away and things like that. You try the same and see whether you are one hop away or not. I can just copy paste here what I got. You can trace it local host also, but obviously that won't make much of sense. Moving on to number 9. It's path ping. Path ping is another ping-based utility. Again, it uses the ICMP command protocol. How is it different than the ping that we basically used? Path ping is a more detailed command. It is like tracer command just now when we used, but a bit detailed in that sense that you can attempt, all these timeouts. You can have number of hosts, the period, the timeout. Then you give the specific IPv4 or IPv6 address or the target destination name, and all can be given within the path ping parameters. Generally, path ping is case sensitive, right? It's typically similar to the tracer, but it would give you more details or it will give you more of statistics when you use this path ping. Let me path ping. And let's see what we get from there. Is path ping ever in other operating systems? If I move to slide number 10, it would show you the syntax of using not on Linux. Maybe MTR. Try MTR, Naveed. Again, if it's not there, you need to install that as well. MTR works fine. As long as MTR or traceroute, they give you the same statistics what Windows gives here. I'm waiting for, it's computing the statistics that I'm waiting for it. I have given path ping command to Windows www.google.co.in. I'm waiting for its statistics. It's taking a little bit of time. I got the statistics here. Yeah, I'll copy paste these statistics here. Okay, others also have got this. And we can see here the comparison between the trace route and pathing is that certain statistics have been given, certain statistics have been computed within this, like hops, RTT, send to here, lost send packets to this node, address domain, and so on. Akif says, unlike tracer, pathing stops as soon as it encounters a router that doesn't respond. Maybe that's the reason. I'm not sure about it. Did you try the same command for the same address? And see if it's the address is same, yeah, then maybe that's the reason. Let me just see. Yeah, number 4, it has not responded, so it stopped here. Trace, it is complete. Yeah, in this case, there are certain options like lose hosts. We can change them and get them done that way also. How about others? What did they get? Like, for example, R is there to see if each hop is RSVP aware. Timeout for each apply. We can keep a shorter time, then it can move on. We can try different options here and see how it will act. Others also had these kind of problems. All right. Now I have the slide number 11, which is enhanced ping. Enhanced ping, there are several utility softwares for ping. I mean, you can Google utility softwares for ping and you can see there are a lot of free ping tools which will help you. The difference here would be that, okay, if you'll check it, you'll respond back to me and see what is the issue there. In the meantime, I'll move on. Right. Like I said, there are different options of ping, which are software based or tool based options, or utility based or graphic user interface based utility softwares. One of them that I mentioned there is TJ ping. Okay. There are plenty of others. What you can do is go to internet and download some of them and try. Typical one is PRTG network monitor, a good one. You can have ping dom. Some are free tools, some are paid tools, right? There is EMCO ping monitor, there is ping info view. If you just simply try those, what you will get is, like I'll move to the next slide, you will see that you have a place wherein there is written host, slide number 12. You just need to type in the IP address and then ping. It's written there on the right side, lookup, trace, and so on. So what you are doing using your command prompt, this would give you using a graphical user interface. There is also set option available there. You can use this set option so that you can set like -H, -L, and so on. These options you can simply key in using the interface. It's not that different, it's just that it is, user friendly, because you don't have to type in at the command prompt. And the output that you receive looks in a better way. And it shows, below the statistics that you used. What was the packet size? 64. Timeout was 5. Packets was this. You can try this TJ Ping software, downloaded it and see it. Or like I mentioned, PRTG and so many other monitors. Power Admin is also there. ICMP Ping Tool Monitor is also there. Ping InfoView is there. EMCO Ping Monitor is there. Plenty of these which can work in a similar fashion, which basically uses at the background ICMP tool. Some give a very detailed very detailed information about your network that you are going through, like a PRTG network monitor, but it might be paid, it might not be free. Then moving on to the next one is netstat command. This is slide number 13. This command is used to get information about open connections on your system, ports, protocols being used, etc. Incoming and outgoing data, and also the ports of remote system to which you are connected to. Simply type netstat, right? When you see netstat, it would have active connections, right? What protocol it is using, TCP or UDP, to what address it is accessing, what is the local address, and what is the foreign address that is it, and what is the state of it, whether it's established connection, whether it's waiting, or whether it's closed. This is what the netstat command uses. For example, I am connected to you through Cisco WebEx. This should be one of the line within the results of netstat command. It should show me that this is your local address, then there is a colon and there is a number like 62755, which is a port number, and then it would give the address to that I am connected to, and lastly whether it's established or not. As an example, I have just copy paste here. This is the netstat. And what is netstat? Basically, it gives the network statistics. How is it different than the previous commands that you have used? It is typically showing your statistics, information about your computer, who you are accessing. You can get to know maybe some other software within your system is accessing internet and sending data. You can get to know what connections have your system established with other systems. What protocol is it using? Typically, it would return you the protocol, the port number, your address, your IP address, like I have 192.168.1.9, and then it's a colon 363019. That's the port number it's used. What is the number? We'll be studying that in future classes. And then the IP address to what I am connected to using protocol HTTPS, which is secure HTTP, and the connection is established. And among all these lines, there would be some lines through which I am connected to you. Means the software that I am using. Netstat, how about Linux? Mac? All right, fine. So Netstat works fine for all. Keep in mind, it is the ports, protocols, connections that your system is having, ingoing and outgoing data using this. Several options are available with netstat command, like -A displays all connections and listening ports, -E displays Ethernet statistics, displays P-P protocol used, or displays the routing table. This is interesting if you want to see the routing table through which you are going. This command, when we understand the routing, we'll use this command to understand what is the network destination, what was the net mask, the gateways, and the interfaces that we have used. As of now, you will try all of these options, right? I believe your assignment should have that you would try all these options one by one and take the screenshots, and then you'll send the assignment. There is S for protocol statistics as well. You'd get to know. We would use another software through which we will get the details, what we know as Wiresharks. That will be part of it, part of our work as well. Use netstat-s and a long list of statistics would be there of what is sent, what is received, number of active connections. This gives the statistics of the total, network usage that you have done here. Moving on to the slide number 14. Slide 14 gives you details about netstat live. Have you ever wondered just how fast your network connection is? Like you use NetSpeed and so on, speedtest.net. Not just how fast the modem is connected at, but how much data you actually can get. Netstat Live is a small, easy to use TCP/IP protocol monitor which can be used to see your exact throughput on both incoming and outgoing data. Yesterday we took this term throughput, that is the actual data, actual useful data that is sent across the network, that's sent across the link over a period of time. This is Netstat Live. You can download this application as well. Now, slide number 15 shows the screenshot of this Netstat Live. You can download it and see how it works. See, you can see incoming, outgoing, what is the average. Like you use speedtest.net, typically this would also give you what was the average of the speed that your system had, your network had. All right, I think, how many have we done? How many commands we have more? Madia, we have some more commands. Okay, we'll take it in the next class and then we'll move on with our class as well. As of now, you try these commands. Right, we'll stop here. Ramanan, you have recorded it, so you'll be uploading it in the class as well. Do we have any questions as of now? Okay. Others, regarding the assignment, let's wait for a while till we finish this one. No assignment as of now. Once these slides are finished, then I'll give you time to try. As of now, just try these. Okay. All right. Okay, then I'll see you in the next class. Next one will be again a theory class. We'll first finish these commands and then we'll continue with packet switching with network switching. All right. Okay, then. Take care. Stay home, stay ahead. Bye bye.